Today we are going to see about which of the following are convergent in the following options. So for to find the convergent sequence, we need to know about the test of convergence of the positive term series. So the tests are four different tests: a ratio test, a root test, integral test, and then test of divergent. So the ratio test is nothing but limit n tends to infinity a n plus 1 divided by a n if it gives some value. If that L is less than 1, then the series is convergent. If it is greater than 1, it is divergent. L equal to 1 means the test fails. In the same root test, limit n tends to infinity, we use a n plus 1 divided by a n. So here a n power 1 by n equal to L. If L less than 1, it is convergent. Greater than 1, it is divergent. L equal to 1 means the test fails. And the integral test is nothing but a n equal to f of n. We choose that function of n, and we put in the integral form of 1 to infinity f of x dx is convergent. If it is convergent means, then if the integral term is convergent means, then the series also convergence. Or otherwise, if it is not convergent means, then it is a otherwise it is a divergent. And it is a test of divergent. So if limit n tends to infinity, a n is not equal to 0 means, then the series is divergent. Okay, the following options are given here, so we choose the first option. So first, limit n equal to 1 to infinity a n, summation n equal to 1 to infinity n square 2 power minus 2. We use the ratio test because it is in the power of it is in the positive terms of n power. So we use ratio test. Limit n tends to infinity a n power 1 by n. So we know the form of limit n tends to infinity a n power 1 by n. So our a n is nothing but n square 2 power minus n whole power 1 by n. So if we multiply means n square power 1 by n 2 power minus 1, this is minus n. So here n power 1 by n getting cancelled and minus 1. So if we put inside 1 by n here 2, then this is 1 by 2. We know that since limit n tends to infinity, n power 1 by n equal to 1, so this term will be 1 and this is 1 by 2, so 1 by 2 less than 1, so this series is convergent. So we get one convergent sequence. So our question is to find the convergence sequence. So next, limit n tends to infinity a n power 1 by n. Our a n is nothing but n power minus 2 2 power n whole power 1 by n. So n 1 power 1 by n into minus 2, and then 2 power n into this n getting cancelled. We know that limit n tends to infinity, n power 1 by n is 1, so 1 square into 2, so 2 greater than 1, so it is a divergent. And the third function, it is in the form of fractional part, so we use the integral test. So a n equal to f of n. So we put in the integral form 1 to infinity f of x dx. If it is convergent means, then the summation is also convergent. So a n equal to f of n, that is 1 by n log n. So our limit is 2 to infinity, so integral 2 to infinity f of x dx. So 2 to infinity n log n is nothing but 1 by x log x dx. So 2 to infinity, so we write 1 by x log x. So we know that f dash of x, f of x means we write log f of x. So log f of x, if we put the derivative means it will goes to side. So it in the form of log, if we differentiate log x means 1 by x, so log x to infinity to 2. So if we substitute the log into log infinity minus 2 in one infinite term, one finite term means minus means we get the infinite term. So it is less than, it is greater than 1, so it is a divergent. And next term is n equal to 2 to infinity a n, that is 1 divided by n log 1 plus 1 by n. Log 1 plus x is nothing but x minus x square by 2 plus x cube by 3 minus x power 4 by 4. a n is nothing but our a n is this one, 1 divided by n log 1 plus 1 by n. So 1 divided by n into our log term can be expressed as this, like this. Instead of x we have 1 by n, so 1 by n minus 1 by 2 here 2 as it is, and we have to power the terms. So n square plus 1 by 3 n cube minus 1 by 4 n power 4 etc. So if we cancel the multiply the n and cancel the n, means we get 1 divided by 1 minus 1 by 2 n plus 1 by 3 n square minus 1 by 4 n cube. So if we take the limit n tends to infinity on both sides, means if n tends to 1 by infinity is we know that that is 0, so the left terms are 1, so it is not equal to 0. If limit n tends to infinity a n not equal to 0, means this term is divergent. So this term is a divergent series, so we have to find which one is convergent. So first term only convergence. uh, like this, we using the test of convergence of positive terms to identify the convergence series. Hope you all understand, and thank you.